Hey guys, welcome to Erudio Episode 3, your student driven research podcast. Today we have a special guest over, Harshith Mohan Kumar, not only the founder of this club, but also a research veteran. So, starting it off with, how's your day going, Harshith? How's it been so far?
Hi, good morning. Well, the weather here in Riverside is great. It's quite breezy today, and yesterday was quite sunny as well. How's it going with you guys?
Yeah, it's been alright. It's been a good weekend so far. So, while going through your profile, it was really interesting to see that you came to India for your undergraduate, but it seemed like out of nowhere because it really seems intriguing to see being based in the US for a significant part of your life and then switching sides suddenly. So, what's the story behind that?
Yeah, well, it's a long story. I've been back and forth between here, the United States and India. Um, well, needless to say, well, it was mostly because my dad was a database engineer and he had the opportunity to work in his U.S. office here in Santa Clara. So I grew up between Cupertino and Mountain View and stayed here in the Bay for around 11 years. So when it came to high school, my dad decided that he wanted to relocate it to India, mostly because of family and being close to family members. So when that opportunity came, we shifted back. I did my undergrad in India at PS University prior to coming back for my master's here at UCR.
That's great.
Definitely an interesting
Uh,
experience.
all right. The next question. How did you figure out the right mentor for the path that you've chosen, which is basically ML? How did you figure out whom to approach or like the right mentor that you had to catch hold of?
Yeah, so that's a good question. And I think, instead of just looking at, oh, who is the right person for me, you want to try to answer, what do I want to do, right? What are my interests? If you can figure out like a set of topics that are really interesting to you, that you're really passionate about, then you can quickly go into, that particular area and see who's working on it, whether it be in your university or outside. So to find a mentor, you need to find your interests first.
Right, right.
A quick follow-up question on that. Do you really think it's always the topic that comes first, and not the person who's working? Like, let's say, let's take the example of any university, okay? And let's say I'm interested in quantum machine learning, very niche topic. And does it have to do with my interest there, or does it have to do with what the person is doing? Because not always people really are working in the field that you want to. Do you make do with what's available, or do you just uh, shoot wide to people who are on?
That's actually a good question because, yeah, of course, there could be some phenomenal professors at your university who are just amazing, right? These are exceptional people that you want to surround yourself with. But then you sort of
Yeah,
have to make the decision, right? Are you going to um, let your interests fuel you, your passion fuel you, or have the professor tell you what to do? And at
exactly.
UCR, I did go talk to a professor recently, and that's sort of what he was telling me, right? He's like, okay, I might have like a problem statement for you, but there's no point in working on it unless you find an interest or a passion towards doing it. Because research isn't just about, oh, you do this for a few months and then you have a project. It's like a whole 1 year commitment, 1 year plus commitment. You have to
Yeah,
do literature survey for the first phase, which might be a few months, and then you do experimentation, which might be another few months, and then you have to write the paper. Before submitting it to a conference, you have to review it for months. So all of this is a huge timeline. Yeah, well, that's my answer to it.
So the next question. What factors instigated an idea for a potential research paper, and how do you go about an idea, like pursue it and then make it a research statement? How exactly do you know how to go about it?
Um, Well, you have to sort of really gauge that field or topic at hand. You want to sort of look into recent works and relevant literature and sort of do your justice in figuring out what is the current state of research in that problem. Because most likely you'll think about a certain problem, but a lot of researchers might have done the same thing, right? So search into, journals, conferences, reputable conferences in your domain, and figure out what the authors are putting out. See if any papers are closely matched to what you want to solve, and then take a look at, what holes they have in their paper. So that's how you sort of narrow down your problem statement to something specific that could actually be solved and has an impact back into the world and society.
Okay, a quick follow-up question to that. Uh, how do you, find out or identify potential collaborators who complement your skills and expertise? How do you know you found the right person to work with?
Yeah, that's a great question. Fortunately, I've had great people to work with in the past, and I think that was a crucial factor in putting out very high quality papers. And so when you are seeking out teammates, you want to take into account of like their interests, their skill sets. Do they have the same amount of passion to go out there and do research? Because a lot of people might not be interested in doing research. So you want to try to find someone with a very growth mindset, a very positive mindset of you know not quitting when something becomes difficult, especially because research is it's a constant battle, right? You won't have one solution, one algorithm that solves the problem. It's more about, okay, you try this, oh, it doesn't work, what do we do next? Okay, we can make this little tweak to the problem and try it again, right? So you iteratively search for your solution until you get there, but you won't get there if you quit early on in the phase. So try to pick teammates who are, very passionate, very driven, and who want to get the problem, solved just as much as you do.
That's great advice. Yeah.
Yeah, it might be hard. You can't just go up to someone and be like, "Oh, do you want to do this?" You have to sort of like tell them, build an intuition, or even let it sit, right? That if you see that someone else is doing research in your field, then you might want to go approach them, be like, "Hey, well, what are you working on?" Talk to them, have discussions.
Yeah,
Interested people will always want to talk to other interested people.
and
I think
definitely.
that's
I
yeah.
think in this case, having like a good networking skill would come in handy, right?
Yeah, and even like being part of this club, right? It shows that people are sort of passionate for research. So if you have another friend in this club, maybe they could be a potential candidate.
Oh yeah, definitely.
Yep,
Potential.
totally,
Yeah.
totally.
So besides interest, what are the other factors you use to choose a topic or bit to choose what field you're going to not field the particular problem statement you're working on for your research paper?
Well, I think it's more of like a refining process. You read a lot of literature in the area, and then you go to your professor who's also very experienced in this particular area, right? And they will sort of tell you, okay, wait, look at this. No, look at that. They will guide you in a direction that they think is going to be the most impactful. And they build that intuition over years and years of research. But it's your job as like an author to sort of go out there and read all of these papers and identify what it's missing, where it fails, read their conclusions, read their limitations, right? And read the history of papers that come behind that current paper. Usually there's patterns, there are certain like ideas and concepts that papers just cannot solve. So they edge away. research is constantly a process of edging away towards the solution. No one's just going to come out and be like, this is GPT. It was like, okay, we first introduced self-attention. We made iterations on that. And then we realized if we attach a bunch of decoders, we can get this model that can perform really well, right? So it's always about edging away.
Also, do you feel that there are any particular topics which are dead ends or without any scope? Or is there no such topic which does not have any scope
Well,
when you have been trying with your professors?
no, definitely. I think all ideas have potential. It's just some ideas might be so far into the future that we are limited by hardware, by software, to actually put that into implementation. That doesn't necessarily make that idea have less scope. It's just an idea for the future, right?
What do you
So you
think about like more niche ideas though that people haven't really dug into or explored just yet?
Well, niche ideas are actually good, and they get picked up by the research community pretty well. But you also want to look at what the impact is on society as a whole. You can't just be doing it for your small little use case. It has to have a huge impact.
That makes a lot of sense. Totally.
Yeah. So I have a interesting question for you. Besides being a local legend at PS, you have had a massive lineup of positions at GSOC, Intel, and IISc. Uh, Besides the obvious skills, letter of recommendations, previous experience, and tons of grinding, what do you think is that one key secret ingredient that got you there to securing such internships?
I was fortunate enough to, find my passion very early on into my undergraduate studies. Especially by first year, I honed in. I was like, okay, I wanted to learn more about machine learning and deep learning. So, instead of focusing on my bio exams, I was learning about neural networks. I was learning about loss functions, optimizations, and stuff like that. Um, but I'm not saying that's a good thing. Of course, you should focus on your current studies as well. But that's the thing, right? You gotta, in your hours that you're not spending in college, you have to do something with it. You have to spend X amount of hours each day and find your interest and passion. And once you do, don't stop. Just don't be like, okay, this is what I want to do. I'll just take the classes to complement this field. Think about what you can do in terms of projects, ideas, and research. So I started with gaining an interest for ML through the IO courses, PESU IO courses that I took, and I think that's a great introduction to students, especially at PS University, first year students, to get into an idea that they don't know anything about, right? And these peer mentors will teach you a lot. So getting started with like IO courses was great, but then you have to think about, okay, I need to continue to work, be consistent, have a growth mindset towards this field. So I started to do a lot more research, put out publications, and that was the most daunting part. By the end of my first year or second year, I think second year, yeah, I submitted a paper to a conference. And this was something like, okay, I'm never going to hear back from this conference. That's what I thought. But I'm just going to put it out there because I've created this paper. Might as well submit it somewhere, right? And that's how it started. Eventually got accepted, and we presented that paper in a conference that was held in London, but it was virtual because COVID was occurring at that point.
Yeah.
And that was my first paper.
That's
absolutely awesome.
That's crazy.
Thank you. And then from there, it's just like, okay, let's do it again.
Right.
So I have Go ahead.
No, it's fine.
Okay, so I have a quick follow-up to that. So since we just talked about your research interests, all the publications that you've done, is there a thematic pursuit of projects in these internships, that set you up in a good position for your masters, or being diverse and being really all over the place? Does that help?
Well, that's a difficult question to answer because there's different types of masters. There is research as well as industry-based masters
Yeah,
for computer
right.
science. So, do you want me to talk about the research
Hmm.
end of it? Okay. For research, I think the primary factor that they look at in your profile is if you have top tier publications at conferences like CVPR, WACV, ICCV, ICML, all of these top tier conferences, you gain a reputation in the space of research. Um, I think that's a very important factor in your application. Apart from that, they of course they have the filters. They have like GRE scores. They have your GPA, where they can quickly swift through thousands of applicants. Because I would say like maybe 5,000 people might apply to UCLA, but only like 100 people will get accepted.
Hey,
Wow,
So
that's actually pretty
that's
how will
tough.
tough.
they how will they filter out that many people? They're not going to sit through and look at all the applications. They'll have a filter. They'll be like, okay, 8.5 GPA above,
Yeah.
320 on a GRE above, something like that. It's hard to say. So you have to, just try at these academic feats. But you also, if you have internships, if you have these papers on your profile, it sets you up for success.
I think having
Yep.
some stuff under your belt to show that you have some sort of credit to your achievements would definitely help out in like making you stand out amongst other competitors, right?
Yeah, I mean, if you look at my profile, like I wasn't too academically gifted. Like, so by the end of my senior year, my overall CGPA was an 8.09, which is quite low. I mean, especially when you're applying to universities abroad, they want to look at CGPAs above 8.5, above 8.8, or so on. Um, so I think that was a very crucial factor in applying to masters. But luckily here, I did get an admit at UCR, and I'm enjoying it so far.
I mean, I think like the
That's
stuff
great
you've
to hear.
done as personal projects as well definitely help with that because you've done so much, and the scale
Mm-hmm.
of what you've researched and what you've worked on itself has been quite significant and very impactful as well, right?
Yeah, I hope to think so.
Definitely, definitely.
Right. Okay. So, like we were talking about academics and research and all of that going on side by side. So, how exactly did you juggle through all of this at the same time? Like, it must have been really hectic. So, how did you really manage? How did you like prioritize? How did you go about that as a whole?
Very difficult. I remember last year, so I had to write my GRE, but we were invited to France to present our paper. So now it's like, okay, well, I have to figure out the visa process. I have to go through all of this. I have to coordinate with the team to get there. I have to book my accommodations, my flights, and then all of this logistics. And so I was like, okay, well, I clearly have to do this, but then when I come back, I have to, write my GRE once again. I have to write my TOEFL. So last year was a very eventful, hectic year in the sense that, I had to go to France, present, come back, write my exams, and then apply to these colleges. So I think it's really important to be organized, especially with your calendar. Like my Google Calendar is always filled out, either with meetings or things that I have to do. I will just block time for studying, or I'll block time to do, anything, right? That way, it's a very visual thing for me because I look at my calendar and I'm like, okay, on this day, I have to do this. On this day, I have these assignments due. So being organized is really how you get on top of things.
Oh yeah, I mean it definitely helps you like manage time as well, right?
Oh yeah, for sure.
Honestly, like it would be better if you were to, like keep yourself organized as well. It would probably help you a lot in terms of managing yourself and your time.
Definitely. And I think that's, when I was in my sophomore year, like second year and junior year, third year of college, all I did was follow my calendar. I would I would wake up, I would be like, okay, well, at this point, I'm going to do 100 days of ML for an hour. I'm going to stream that. And then, okay, I have these classes. And then, I'd go to the gym, right? And then I'd come back and then I'd be like, okay, what can I study? This is study time. And then every once in a while, I'll have like a 2 or 3 hour schedule for fun. It'll be like, I'll either go read, I'll watch a podcast, or do something that I like to do, go out with friends. So you got to balance everything in a little bit, because don't burn yourself out, right? It's
Oh
not
yeah,
fun.
definitely. I mean, balance
See,
is
but
definitely important, right?
plus, I also think it's really interesting how you manage to stick to your calendar because that's something a lot of people struggle with.
Yeah, that's
You
a
know, a lot of
great
people are good
point.
with making calendars, but
Yeah.
sticking to them is, yeah.
Oh yeah,
Yeah, once you see the results, you realize that, okay, wait, this is a lot more efficient, right? There's nothing better than this. So,
I
Okay.
mean,
Moving to the next question. So, can you share any specific instance where you faced, a significant challenge in your research or academic journey or your journey as a whole? And how exactly did you overcome it? Like, what were the steps you took, or how did you go about that?
okay. Well, I think sort of, by junior year, I wanted to work on this concept of semi-supervised learning or self-supervised learning. Mostly because I was inspired by Jarvis, from Iron Man. I was like, okay, why do we not have, we were doing all this research in machine learning and deep learning, but we still don't have a system that can interact with us as well as like, Jarvis does in Iron Man. Which seems like a very dumb, profound thing to be fascinated over, but that drove the research that I wanted to do. Um, but anyways, like so, we started working on this SSL semi-supervised learning task problem statement, and as I did research, I identified a problem that I wanted to work on and started implementing it in code. And I made a mistake of using TensorFlow to write, the whole framework, the entire architecture. And then I get to the part where I have to sort of modify how a small loss function works within this architecture. And then I quickly realize, wait, TensorFlow does not allow me to do this because it's just high level.
right.
And then, weeks go by and then my professor's like asking, okay, what are the results? Why are we not here? And then all I can do is say, well, shit, I can't do what I want to do with this framework. So, that was a really difficult thing to face because you've done all of this work, you know what you want to do, but you're literally just limited by the tool that you selected. So I had to rewrite the whole thing in PyTorch and then see if PyTorch can support that. So I think that was a really difficult thing to face because, in research, you realize that it's not just the idea, not just a problem statement, but it's a combination of software engineering as well. You have to know your tools, your frameworks really well to understand where you can go in and do what you want to do.
Oh yeah.
So,
I mean, yeah,
I bet rewriting the entire thing in PyTorch would have been a painstaking task as well.
wait, is that a question?
Oh no. I mean, it's good for me though. Yeah. But I know how it would have been.
so obviously, running through your journey for a while now, we've seen that you've done a lot, and you must have learned a massive amount of knowledge, interacted with like a massive amount of people. What is one thing that you learned along the way that sticks with you to this day? That one takeaway. If you could, state a thing, a conversation, or whatever, one line. what would it be?
It's the concept of having a growth mindset. And I recommend everyone to read this book by Carl Dweck called Mindset. And,
Yeah.
it's maybe I have the book. Actually, maybe I gave it away. I think I gifted that book to someone. Um, but, anyways, this book by Carl Dweck on mindset, it really it's about building, your core principles in a sense. If you're solid in the principles that you have and you tackle everything with a growth mindset, you never give up. You always work towards a solution. You try to figure out what are the failures in yourself and not in others. Then you can work towards improving yourself, having like a happy life too. Yeah, I mean, till this day, I might know concepts in computer vision, but that doesn't matter because you know a few days from now there might be a new paper, a new topic, a new algorithm that comes out that I'll have to learn. But what will stick to me is the fact that when something new comes out, I'm not just going to be like, oh, I don't know this. I'm not going to look into it. It's too difficult for me. I will go into it being like, okay, I have to learn again. Here we go. Right? It's all about
The
improving yourself.
yeah, so the roadblocks don't become a disappointment anymore. They just become, a higher standard to learn and jump beyond.
Exactly. Yeah.
That's absolutely fantastic
That's
advice, honestly. Like,
yeah.
I think a lot of people need to have that mindset in order to like not only improve themselves but their like knowledge as well. Like instead of
Hmm.
facing a challenge and then giving up, like try to, delve into it more and understand.
I think it's a desirable thing. Just more outside the research setting as well. Just in general, it's gonna help.
Lastly, do you think, as being someone who's into AIML and stuff, do you actually think there is a limit towards where AIML can reach, or does it have no bounds? For example, there have been talks that there are certain creative tasks AIML can't reach. For example, people think it can't create compositions and stuff on its own, despite the fact they've already started doing some extent. So, do you actually think there's any task which you foresee AIML not being able to do, or any such limit in the bounds of AIML?
Ooh, that's a good question to ask. And I'm not experienced enough to answer that question. No, but I can give my opinion on it, that's for sure. But you have to take my opinion with a grain of salt. um, if you have listened to the Lex Friedman podcast, he has
Yeah,
amazing, yeah, he has amazing people on his podcast, like Joffrey Hinton, Jan LeCun, uh, all of these
he had Ivan.
phenomenal, right? Like Turing Award winners, in the field of ML. Joshua Bengio, I'm pretty sure he's had. The thing is, Lex always asks this question: do you think, ML can eventually be self-conscious? Will it reach AGI? Does it have the potential to solve everything? And I feel like most of these researchers give a very similar answer. But mine is a little more optimistic. Mine is like, yes, I think in the future that, machine learning and deep learning will be able to solve most problems, including creative tasks. And that's a very optimistic mindset to have. Um, but of course, there are limitations in hardware as well as storage and computations, and fundamentally in the algorithms itself, that it won't be able to solve everything. For example, I went to my professor recently talking about a task that involved machine learning as well as physics and optics.
Okay, that's interesting.
Yeah, so we have certain cameras and sensors that are able to measure different wavelengths. RGB is within a certain small visible wavelength of light, but there's also thermal, there's near infrared. You know, how can we I was trying to think about how we can extract those extra wavelengths from just an RGB camera using machine learning. If you're able to detect, a person, you might realize they have certain materialistic properties, like their skin radiates heat at a certain property that's different than a wall, and those are static properties, right? But can we do all of this? No, maybe not, because there's limitations in the sensors itself that's able to capture the data. What machine learning is just it's finding patterns in your data set, and it's trying to build a model on top of that. So inherently, it's very limited. But maybe in the future, we might have like self-learning, semi-supervised learning that's able to solve these tasks.
As a related follow up to this, what exactly do you think about the whole idea about AIML potentially being able to prevent all the diseases beforehand itself, basically predictive diagnosis, and potentially leading us to be near invincible or near gods? Basically, I think there was one book by Yuval Noah Harari talking about how, with the way IML is going, it can lead to a point where nearly every disease can be cured beforehand. We reach near invincible levels. I think it's Homo Deus or something. He had a book. Do you actually think unless that level of the diagnosis is actually possible? Because after all, it's the body. So as you get to a certain level of understanding, it might actually be possible. But I don't know actually. No, I'm not my field either.
No, I don't think machine learning will be able to solve all diseases, especially in the health in the health field, health sector. I am very skeptical of having machine learning models perform there, mostly because they're black box models. They're unexplainable.
Mhm.
You could maybe have like a random forest implementation to give suggestions to doctors. I would never trust a fully deep learning system to take care of our health, health industry, health. Models make mistakes, right? We know that. We know that, okay, maybe it performs 99% accuracy for a certain data set, but have you tried it with another data set? You'll realize it only gets like 50%. As researchers, we're able to make these models perform really well in a very narrow and specific task. But once it sees the real world output, it's not that great. Like Teslas get into crashes. I'm not sure if you saw the news a month ago. Cruise, one of their vehicles, ran over a pedestrian in San Francisco and dragged her 20 feet across the road. It's one thing to hit a pedestrian, but it's another thing to drag them, 20 feet across the road. And this is supposed to be a model that's, safe for the roads, where these cars are constantly on the roads operating. So I'm optimistic for the field of machine learning and deep learning in the sense that it can solve a lot of problems, but it's not going to be able to solve everything. That's for sure. And it's not going to be good at everything as well as we are.
There are definitely things like you wouldn't want to get a misdiagnosis if suppose you have a deadly condition, right? That would be pretty dangerous.
Yeah, and I would think more of it as a tool rather than a solution.
Right, right.
Definitely. Yeah. So
Uh,
before we close it, I had a very small question. So, being in your position right now, what do you think are the set of tools or set of topics that one should aim to look at to delve into research in AI/ML at this point today?
There are a lot, actually.
Possibilities everywhere.
Okay, so I would say I'll give you two different viewpoints, one from research, one from industry. From the research standpoint, like you want to know all of your fundamentals, like your core algorithms. Like you should know, random forest, SVM, naive Bayes theorem, and all the mathematics and probability that builds these algorithms the way that they are. Um, Neural networks, like you should understand like what back propagation is and be able to explain how you take the gradients of a loss function and why that gradient leads you to the most optimal set of weights, right? These are very core ideas that shape the way that you think so that you can solve new problems. And it's also like allows you to look at a research paper, understand what they're doing in steps. So when you see it in steps, you can say, hey, in step 4 point something, they're missing this key. If I just insert it here, maybe it makes the entire flow of equations a lot better, more efficient. That's from the research point of view. From industry, you should know a lot more about implementation. You know, your tools, TensorFlow, Keras, PyTorch, Lightning, all of these different frameworks. Like you should be really good at modifying and operating with tensor data, matrix multiplication, even parallelizing code with GPU. You know, do you know CUDA or not? How the wider range you can have, the more you can do. And I think it's complementary, right? Because you can go into research, you see this step needs to be added here. But in order to do that in your code, you got to know which tool to pick to make that modification,
Definitely. Yeah.
right?
Makes
So
sense.
maybe in an equation you want to do a transpose of a particular matrix before doing a dot product. Can you actually do that in your code? Like how do you transpose a matrix using PyTorch? Things like that, yeah.
Before
Yeah.
we wrap this up, I have two quick questions for you. So, the first one being, how strong do you think the moral limitations on future AI/ML projects should be?
So there's this book called The Alignment Problem, and it talks about the limitations that machine learning models, deep learning models have, in the sense that it's not able to align towards societal values. So things like, Microsoft or Facebook might have put out this huge model, but inherently it's racist. It might be sexist, and you don't want models out there, being sexist or racist to
Right.
give suggestions back into society. And there's multiple, problems that I could pick out. Once the U.S. government was using models for their judiciary system, and you can imagine how bad that would become
Oof.
because these models every time a person of color would be convicted of some sort of crime, they would have a higher rate of a bigger punishment than someone who is white or a race that is different. These racist systems should not be implemented, right? Like,
Right.
so the
Definitely. I
moral
mean,
of
that
this,
would definitely
the
question
moral of
this.
this, yeah, like the moral is like like the models do good only on data that they have seen so far, and we as humans have created data that might be very biased, that might not be true. Um, so we can use it as a tool to take suggestions from, but ultimately you have to pave your own path. And as humans, I think we just have that level of understanding in one another that systems just cannot be able, they won't be able to understand.
And coming to the ultimate question, so a lot of people, generally go abroad to do masters or try to find a job. Since you yourself have like transitioned from countries a couple of times, US to India and then back to US, did you find a lot of challenges? Like, did you feel like the learning curve was a bit more, or did you like run into any sort of huge challenge that you were unable to like conquer without any help?
Well, shifting from India to the US is quite easy because, in India, you are very driven into theory.
Right.
But I also grew up here where I did a lot of experiments. I was part of a robotics team. In fact, this is a robotics team that I was part of. It's called Valkyrie.
Oh, cool.
Where it's called Valkyrie Robotics, and they participated in this competition every year called FRC, First Robotics Competition. So I had a very diverse mindset when it came to learning, where I could do practical and theoretical. So it was okay for me to adjust. But if let's say if someone does come from an Indian education into the US, they will find it very challenging because here in the US there are constant quizzes, constant assignments, programming assignments to do every day. Right? It's not like you have two midterms and one final. That determines most of your grade. You have to do small homeworks every week, and they contribute a significant amount to your grade. It's not just 5%, 10%. It's like 40%. grade is homework, quizzes that you do weekly. So that's the difference here in learning. I hope that answers your question.
Oh yeah, definitely. I think that would be very helpful to like the people who are looking to go abroad for higher studies or people who are just coming here and trying to learn easier ways to transition. And
Mhm.
I think with that we can wrap up this episode of Erudio. Thank you so much, everyone, Prateek, Aryan, and Sowmya, and special thanks to Harshith for taking time out of his busy schedule, I'm sure, to come and give us a lot of insightful feedback.
Thanks for spending the time with us. It was really helpful and it was so fun. We learned a lot.
Well, that's
It was
good.
a great time.
Thank you so much. It was really nice talking to you, getting to know a lot of things from you. It's really nice. Thank you so much.
Yeah, well, thank you guys for putting this up, right? I hope everyone enjoys
Oh, yeah,
watching this.
definitely. It's definitely a must watch because this is really, really interesting for sure. All right. Thank you so much, guys. Have a good day. Have a good night for all of you here.